This is part 1 in the series Congruent Triangles. In this series, we're going to investigate many different aspects of triangles. We're going to first classify triangles by sides and angles, and then we're going to talk about relationships within triangles and among various triangles. So let's just get started here, and let's talk about the different types of triangles. Triangles are normally classified in two different ways. We have classification by sides and classification by angles. So we're going to start with the sides, and we're going to take a look at each one of these one at a time and see if we can discover some new information that you may not have seen before. So our first type of triangle is a scalene triangle. And a scalene triangle is simply a triangle with no congruent sides. Now, it's a very important note that we made earlier in earlier units. Never ever trust the picture, because unless you're given specific information about that triangle, you may be tempted to think that one type of triangle is actually another. So for example, if we draw a triangle, you may look at this and say, oh, looks like all those sides are the same length. But you never know. Unless they give you specific information, you're going to end up being fooled, because it could actually be something like this. I could say that's 3, that's 4, and that's 5. And obviously this is scalene, but it looks like it's equilateral. So never trust the picture. Scalene triangles are triangles with no congruent sides, despite what they may look like. And now let's move on to isosceles triangles. There are two schools of thought for isosceles triangles. On one side, some definitions hold that an isosceles triangle is a triangle with at least two congruent sides. And on the other side, the definition is a triangle with exactly two congruent sides. Now, for our purposes, we're going to use the second definition. The reason is because it can cause some confusion with some people, because you could say that with the first definition, if a triangle is isosceles, if it has at least two congruent sides, then an equilateral triangle is also isosceles. So which is it? There's no definitive determination. It could be either or, depending on your situation. So for our purposes, we're going to say that an isosceles triangle is a triangle with exactly two congruent sides. Equilateral triangles, as you're going to see, have the same properties as isosceles triangles, but more of them. So we're going to make that distinction right here and now. Now, when you're classifying triangles, sometimes there's a temptation to mix the two classifications. In this case, we're classifying triangles by their sides. Let's draw another triangle here. So here is another triangle. Now you may be tempted to say, oh, that is a right triangle. Two things of note. Number one, never trust the picture. This may look like a right angle, but there's no mark here indicating that that is a 90-degree angle. But even if there was, this doesn't mean that this isn't an isosceles triangle. So be careful about your distinction. Even though we can classify this as a right triangle because of that right angle, it could still be isosceles. And the way you would tell that is if there are these little hash marks over here indicating congruence of those segments. So if this segment is congruent to this, even though it's a right triangle, it still can be an isosceles right triangle. So let's move on to equilateral triangles. To start with, notice how you spell equilateral. It's E-Q-U-I, equi, not equal. Even though equi means equal, it's spelled equilateral. Lateral means side, so equal side. So an equilateral triangle is a triangle with all three sides congruent. And there's really very little confusion about these except when you look at pictures. And as usual, never trust the picture. A triangle is equilateral if it has these three hash marks. Now, you may be given information that allows you to show that another type of triangle is equilateral, but explicitly stated, this is how you're going to recognize an equilateral triangle. But we're going to see throughout this series that you're going to find various ways to show that triangles are equilateral. So now let's go ahead and start classifying triangles by their angles. And we'll begin with acute triangles. Acute triangles are triangles whose interior angles are all less than 90 degrees. Now, just like with every other shape that we're going to look at, we can't normally tell whether a triangle is acute, isosceles, obtuse, right, what type it is just from the appearance. However, at the risk of contradiction, from time to time you may be asked something like this. State what type of triangle this triangle appears to be based on its angles. Now, in that situation, then you have no choice but to use just the visual information in the picture to try and figure out what type of triangle it is. Now that's not so bad, because if we were to take a look at what we think might be a right triangle, it would be something really roughly like this. You could see that if this thing were slanted in, you can see that this would be less than 90 degrees, and so would this, and so would this. If, on the other hand, it were slanted this way, you should be able to see that this is moving greater than 90 degrees. So 90 degrees would have been here, and moving that way would have been greater than 90 degrees. So there is a way that you can kind of guess from the picture. Since this thing is moving this way, you can see that that's a little bit less than 90 degrees. So we're going to call that 90, greater than 90, and less than 90. So it's a very, very rough gauge, and you can't bank on it. But from time to time, you may be asked what this appears to be. And so I just wanted to show that to you just for future reference purposes. So again, an acute triangle is a triangle whose angle measures are all less than 90 degrees. And now let's move on to right triangles. Right triangles should be fairly familiar to you. A right triangle is a triangle with exactly one right angle. You may see the definition, a triangle with one right angle. This definition may appear a little bit redundant. If you think about, can a right triangle have more than one right angle? And you might have a knee-jerk reaction and say, well, no. But why? Well, the reason is because we're going to learn a little bit later on that if we add up all the angles of a triangle, they're going to be 180 degrees. But more importantly, if we look at what is a triangle is a closed plane figure with three sides. Now, in order for that to be closed, this angle has to be such that this segment is not parallel to this segment. Well, if this angle were a right angle, what we would have, if you remember from an earlier unit, we would actually have two lines cut by a transversal. These angles, let's extend this a little bit. These angles would then be considered consecutive interior angles. And since they're both 90 degrees, those angles would be supplementary. Well, the theorem that we looked at said that if two parallel lines are cut by a transversal so that the consecutive angles are supplementary, then the lines are parallel. That would mean that this side of our supposed triangle and this side are parallel, and they would never meet. meaning that this would never be a triangle. Now, if this angle were 89.999 forever, this may go out a couple 100,000 miles, but eventually these two would meet, and these lines are not parallel. But because of this mark and this mark, these angles are 90 degrees, so this cannot be a triangle. So that's why you can't have more than one right angle in a triangle, because it wouldn't be a triangle. It wouldn't even be a polygon, because a polygon is a closed plane figure with 3 or more sides. Now, before we move on, I want to cover something that we talked about earlier, and that is the fact that even though a triangle is a right triangle, it can also be classified by its sides in different ways. So, for example, you could have an isosceles right triangle where this side and this side are congruent, or you could have a scalene right triangle in which all 3 sides are different. The only thing you can't have in a right triangle is an equilateral right triangle, because in a right triangle, the hypotenuse, which is the side opposite the right angle, has to be the longest side of the triangle. So let's move on to obtuse triangles. An obtuse triangle is a triangle with exactly one obtuse angle. Recall that an obtuse angle is an angle whose measure is greater than 90 but less than 1, and the restriction of having exactly one obtuse angle: if you have one angle that's greater than 90 and a second angle greater than 90, obviously these two sides are not going to meet. They're diverging, going in opposite directions. And so now let's move on to equiangular triangles. An equiangular triangle is a triangle with all 3 interior angles congruent. Now, this sets up an interesting property. If all 3 of these angles are congruent and all the angles have to add up to 180 degrees, then you have 180 divided by 3, which is 60 degrees, which means that every one of these angles is acute. So that means that an equiangular triangle is also an acute triangle. Now, remember earlier we stated that an obtuse triangle could not be right and a right triangle could not be acute. In this case, we have a classification by angles, equiangular, that can be equiangular and acute. So remember, don't get confused with that distinction. An acute can't be right and it can't be obtuse, because that deals with the measures of the angles, one being less than the other. So with acute, that's less than right, which is less than obtuse. But with an equiangular triangle, it is in this region. So because an equiangular triangle has measures equaling 60, it qualifies as being an acute triangle. So that's why equiangular triangles don't fit that restriction of an acute can't be a right, which can't be an obtuse. So let's summarize what we have so far. We've classified triangles by their sides, with scalene, no congruent sides; isosceles, exactly 2 congruent sides; and equilateral, all 3 sides congruent. And then we've classified them by their angles. Acute triangles, all angles less than 90 degrees; right triangle, exactly 1 right angle, 1 angle equaling 90 degrees; obtuse triangles with exactly 1 obtuse angle, an angle greater than 90 degrees but less than 180; and an equiangular triangle with all 3 interior angles being congruent. So I hope that clears things up for you, and let's move on to the next section.